like that like filters me in any way, but I don't know about you guys, especially because I'll put it up on YouTube. Okay, so I talked to Jeff a bit, and I talked to some students, and I won't be discussing the assignment 2 right now at all. And the reason for that is that assignment to me was due on Monday, so the work kind of should have been done, and that extension was to kind of polish your report. Right? So if you had to do more analyses, you did more analyses. But at the end of the day, really one of the things we were trying to convey is that, well, one, Jeff might not tell you this, for PhD students, this is a qualifying class. So that means you get a C or below, you have to retake the class. Right? So just to be aware, grades kind of matter in this class. Master's students, especially, I don't know if it's a qual for you, but usually the same deal applies. And also, masters, people who have masters, people still, for some odd reason, I think, do look at your grades sometimes for hiring. I think that's a little silly, but they do. So just be aware of that. That being said, I don't see any of you guys like really getting C's, but I will say that if you were to have handed in the first, like, a lot of the reports as qualifying exam reports, right? Not many passes would have been given out, right? So just to be aware of that, and so that's what we're trying to kind of prep you for in some respects. I don't know if they're still doing that. I have no idea what the curriculum is like. I don't know if you have to take this kind of thing, but the qualifying exam used to be you get an analysis. You might have no idea, or you have never seen that type of data before, and you have 3 days to do it. And you have 3 days to write a report, right? So that is pretty tight of a timeline, but that's not to say that's out of the realm. If you're talking about it to a data scientist, that you get some data, you got to generate at least some sort of report within a week, right? Analyze it, not clean it completely, but just give a report that kind of gives you a full rundown summary. So I think Jeff, in his email, talked about a lot of things. So your paper should have introductions, methods, results. Now, I think when I started out, methods and results were the most confusing sections of a paper. So methods is pretty much just what you did, right? In the sense, like I fit a model, I did exploratory data analysis with like these type of things. I use these packages, I use these methods, that kind of thing, and where the data came from. Right? So one of the things I found in some of the reports I looked at, people said, this is the data, right? And, that's fine, but that tells me you guys trust the data you get. And I don't trust any data I get from no one, for the most part. So in the sense that I investigate all my data, but not only that, if I get data off the internet, I'm very skeptical of it. The only ones I trust higher are probably the CDC or government agencies where the data has supposedly been checked 20 times before it's been released. So that's just an aside on data quality, which if you get data from somewhere, this current assignment, it's not that big of a problem. But you should be saying, we had one subject. We had this much time over him. And after we did some filtering, right, we had blank number of days to kind of analyze, or blank number of minutes total, something like that. So that kind of thing, describing the data kind of relatively completely in your methods. There are some disagreements where certain things go in results. So kind of what came out, right, is what results really is. So for example, you fit a model in the methods section. One, if you fit a model that you can write down, it's a good idea to write it down, right? The second thing about that is, if you fit a model and you did some model checking in results, or that would go in results, because that is the result of the method, right? Even though model checking in some respects is a kind of a method in some respect, right? That is the byproduct of the model, right? So that would go in results, for example. Okay, so the diagnostic, R squared or mean squared error, that would be a result, not necessarily in the methods. Okay? And it's always good to give kind of a soundbite conclusion at the end, whether that be a paragraph or a few. And although we don't require it for any of the papers you guys write or that kind of thing, assume nobody's going to read it. I never assume anybody reads anything over a page that I write. So abstracts for your papers, try to make them as succinct and like as pointed as you can, right? So I don't nearly read enough papers. But when I do, what I do is, I think Jeff ran this down, like maybe like people will skim the abstract, like that's like 80% of people, right? Maybe like, conditional on the people who read that, maybe like 40% of them will read the conclusions or like look at the figures, right? They don't even read before they do anything. They'll like just look at figures and then like keep whittling that down and then get to like 2% of people who like read your paper. So that's why the figures have to be really on point and the abstract usually is really important. And so what I want to talk about a little bit today is like what kind of makes a good figure in some respects and try to like talk about how to change some of that stuff. And I'll primarily be using ggplot. But if you guys want to see any type of plot and any base or anything like that, we can talk about that. So I want to have a little discussion. What makes a bad plot? We'll go around because everybody should be able to give something. No labels. Too small to read. Not clear how?
Like the essential information about
So kind of no context. Okay.
no title, x-axis, y-axis, the variable name doesn't make sense. It's original.
So it's labeled, but it doesn't make sense. For example, like it's labeled, but that doesn't mean anything. Okay.
No units.
No units. No caption.
Scales are inappropriate.
Scales are inappropriate.
Too large margins.
Too large of the margins. Good.
Doesn't add anything to your point.
Doesn't add anything to the point. That's probably one of the hardest to kind of diagnose.
Too little information.
Too little information. So it adds something, but not really a lot. Enough to warrant a figure, for example.
Pie chart is the worst.
Pie chart? A pie chart is the worst. Why is the pie chart? Why is a pie chart the worst?
Well, like Jeff talked about it last time, he said like human eyes cannot actually recognize and difference between different angles. So that's the reason why a bar plot is better than pie chart.
So you have a bar plot. So what does a bar encode? Encodes one piece of information usually, right? Why do you need a whole bar? Why not a dot? I mean, these are things like to think about when you're plotting things. So there has been some stuff that people believe that, certain people can understand like square areas a little bit better when you're comparing things. I would say for bar charts that might not be the case. And then you have bar charts, right, that have confidence intervals or you don't. So a lot of times, I think one of the most confusing things is a bar chart with like whiskers. And that usually those whiskers can be one standard deviation, 2 standard deviations, or 2 standard errors, right? So the standard error is a confidence interval. The 2 standard deviations is just 2 standard deviations. The 1 standard deviation is 1 standard deviation, right? Like so, if you thought the data was like normal, the 2 standard deviations would be pretty much like 95% of the data, like pretty much is in here. So that's kind of giving an estimate of where kind of the data fall. But my preference is put some of the data on there. So if we're talking about like a bar chart where we're talking about means, I would prefer potentially a box plot, for example. I would maybe prefer a box plot with some of the points overlaid. And not by some, I mean all of them, like kind of jittered. So for example, don't pull that up. Let's go. Okay, box plot with points. So I pretty much use Cookbook R like every time. I think it's Cookbook R. Like anytime I'm doing like the majority of stuff in ggplot, Cookbook R is really good for a lot of that stuff. It's got code. It's got all these fun things about densities. It talks about bar charts or box plots. But let's just do one. Okay. So what are we doing? It's going to generate some data. Just do one simple thing. Okay. Also, most of you might notice I don't use the ggplot function really ever, just because I never started with that, but it is a very good function if you're starting out. So, by the way, you guys gave great examples as to why or how there's some bad charts. Hold on. Just do density for now. That's just silly. I think that's not what I wanted. What? Switching around. Sorry about that. Y equals x, x equals 1. Box plot. Great. Looks terrible, right? Well, I mean, this is like way too big, right? What are we coding here? We're coding like, maybe like anywhere from 5 numbers to 7 numbers, maybe to 8 numbers in the sense like, right, the box is just the 25th, 50th, 75th quantile, and then the top, for example, is encoding the max. This dot here is encoding the min, and this is encoding something that's like not even really always easy to see. For example, it's like 1.5. So how do you determine? How does a box plot by default determine an outlier? Who's done a box plot before? Who has never done a box plot? No one. So what are the dots? Why does it make some? How does it make some dots? So you take 75th minus 25th, right? Multiply by 1.5. Add on either side. Anything outside that range is a dot, right? Exactly. So, not surprisingly, we don't get a lot of dots because, for the most part, I did R normal, right? What if I square it? We get a lot of dots, right? The box plot, really, for a lot of things, is based on somewhat symmetric unimodal data, right? It's still a good description of data, but like if you have highly skewed distributions, sometimes this like automatic selection of outliers might not be that good, right? But if you have relatively unimodal data, it can kind of determine some of the tails, but sometimes it's just really bad, especially for like skewed distributions like the chi-square. Let's put this over here. Okay. Oops, sorry. All right. How would you put the points on there? I've seen a lot of ggplots in people's homeworks. So how do you put the points on? What is it? Plus g on point. Okay? How's that look? It's pretty bad, right? So first off, we want to do 2 things, I would say. Right? So there's outlier dot shape, right? There's outlier dot size, outlier dot color. So tell me how to get rid of the outliers. You all have computers in front of you.
Have the shape, I guess would be shape equals default is no.
Let's try NA.
Yeah.
So NA, we'll take it away. Because those points are redundant, right? Like I plot them once, I plot them again, right? Who cares? We don't need to see them twice. All right, now, someone tell me what's wrong with this plot already before we go anything else. Like, this is obviously not something you should give me in a report, right? It's not polished. Like, first off, I got no idea what's going on here, right? So, tell me 3 things that are wrong with it. Labels, axes.
Box is too wide.
Box is too wide. You're sitting back there. What's his number?
Oh, I can see.
Okay, you can see it. It's on a 6-foot screen, right? But read it now. Read it about now. I mean, it's actually skewing with yeah. Yeah. Well, maybe I'll put the points back on and have you identify where the point is. But like, the problem is like a lot of figures in your papers get small, and so the axes usually scale with it in a bad way. This is not like, in the sense like 1.2 would be small, like very 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 small in the text. So you almost by default always want to set the sizes of the axes, of the labels, of all that stuff to be bigger, right? So how do I do that? Theme. Theme is your friend. Okay? So let's reset G. Also, does anybody not know any like ggplot at all? Like, it's okay if you don't. I just don't want to go like, start doing this stuff and it be kind of totally confusing as to what I'm doing. Okay. Also, probably my examples are like terrible. So I'm gonna use cars. Who doesn't use cars? Everybody uses cars. Like, no cars. If you have never seen cars, you have never read a help page because they're just it's everywhere. Let's do miles per gallon. Let's do that to. What do we got? I don't even know. Cylinders. Okay, let's do that. Well, that didn't work out right. So, since cylinder is a numeric by default, you pretty much have to set it to be a factor, right? Also, note that ggplot likes, like anything character, automatically converts into a factor using alphanumeric ordering, like R normally does. If you put in trues and falses, it treats it as a factor. Pretty much the only thing it won't treat as a factor is numbers. It does some weird stuff with dates, but okay, so we put points on there. They look okay. Let's do this too. Let's make them lovely different colors. Right. Oh, look at that. Now, there's disagreements about legends and where they should go. Ask Elizabeth today what she thinks, because I've taken her philosophy on it. Legends should go inside the plot. Right? Almost every plot I ever do has dead space. Right? Dead space being like, there's nothing here. Nothing. There's no point in that dead space being there. And then adding this much space of nothing. So if you ever read, oddly enough, Tufte view of plotting, I think, something like that. So Edward Tufte. So Edward Tufte, honestly, oddly enough, is speaking in Baltimore. I hear he's spoken this week, and some of the students went there. I think Aaron did, so you might want to ask him about that. So Tufte has like very theoretical views on plotting and stuff like that. So he thinks like there is an ink to information like ratio, right? So like especially when you're plotting stuff like on paper or printing stuff on paper, that if you think of this screen as made up of ink, you're like there is a inherent ink to information ratio on this plot, and your goal is to maximize that, right, while keeping clarity, right? So, and I don't mean like, oh, it has a gray background so it should turn it white, like not like that kind of ink. Like, if you're encoding data, it should be the most useful with like kind of the most compact way of doing it. So if you ever he hates box plots. So Edward Tufte box plot. I think you can see it. There we go. So, oh, come on. Okay. So that is a Tufte box plot in the middle. So Tukey, pretty much all the box plots we've ever known with box and whisker plot, they're Tukey plots. Tufte thinks that's stupid. Tufte thinks that just puts too much ink on the screen. You can tell the same story with this, right? The line's the same. When you stop is the 25th quartile. The dot's the median. 75th quartile is when it starts here and that. Now, to some, that is terrible. And in a sense, like I think a lot of it's because of familiarity. You've seen a box and whisker plot like 100,000 times, right? Tuftes you haven't seen so much. I'm not even going to discuss the second one. That one's super weird for me. But I want to discuss the second one, the Tufte number 1, because it's actually a very useful plot if you're doing like 100,000 of them and you're ordering them, right? So this doesn't take up too much when you have 5, 10, 15 maybe. When you're doing like maybe 50,000 or like 20,000 or like 1,000 actually, these can come in very handy because you can stack them very close to each other, right? So there are different types of even the same plot that can be more useful in different settings, right? So I would encourage you to just like look up like Tufte. He has these like very interesting things called spark lines and how he doesn't think that units aren't important, but sometimes the units don't necessarily matter, just the shape of the graph kind of matters, right? And with respect to trying to show things. But he has some very, sometimes very drastic views on certain things, in my opinion. Like things, he's like, we should get rid of this. And I was like, if we got rid of that, like no one would accept anything we ever did. Okay, so now we got points. So, right, so who would submit this with their paper? Right, nobody's going to say yes to this answer. But who has submitting something like this with their paper or with their report? I mean, I definitely have in like the past. I did that. I was like, it looks great. So there's two things. One, does color add anything to this plot? No. Same redundant information. All right. Sometimes it's more aesthetically pleasing. Sometimes it is easier to see certain things. But like, just because they're different colors doesn't mean they're any better than this. But I like colors, so they're gonna stay. And they make a nice legend. Or no, they don't. They make a terrible legend. But they make a legend. Okay. Tell me how to get rid of the legend. Guides, color equals false. Right.
That's something I have to look up every single time.
So guides, I mean, I love this package, but it just like took things that had names and changed them, right? Mostly for the part that like all the things that had names already, like legend, already was a function. So, now it's like a guide. Also, there's like a whole different grammar to it. But anyway, so let's say we said like Phil is this. There's still going to be a legend, right? What you have to do is you have to change, and we'll make it so like, I'm not just showing you bad plots all day. Let's do gear. Let's do gear. So, now, did some stuff. All right, I plotted some points, but not everything looks great. Well, let's get back to, I will show you like multifaceted things in a minute, but let's get back to the part where I just want to show you a better box plot in some respects. Okay, all I want to show you is take out the points, but then we want to do one thing in geom point. The problem is they're all plotting on top of the same exact thing, and you can have a lot of overplotting in your data. So you want to jitter those points around a bit. Okay? So the position equal identity is not really a great thing for the points, because if they have the same x coordinate, right? If they have the same number of cylinders, they're gonna, and remotely close in the miles per gallon, the MPG that we're plotting on the y-axis, they're gonna overplot the points. So what I'm gonna do So there's position jitter, and you can say a width and a height. So width just means how much you want it to jitter on the x-axis, how much do you want to height is how much do you want to jitter on the y-axis. So let's just try by default what it gives. Talk about the output. Okay, so you see things more spread out. Now you get to see a little bit more of the data. This is a little bit too jittery to me. That's kind of an aesthetic thing, but I still, I don't like it where it could potentially bleed over into the other box plots. So I usually say like height or width, and this is in percentages. So something like that, maybe like 0.2. Okay? So I would say that is a better way, or a little bit better, to show actual data on top of statistics. Right? You can still get those quantiles out of there, but you can see kind of how tightly packed some of the points are. Right? This data is very well spread out, but it's just a little bit better. That is to say, I will say though, if it gets much more complicated, let's say we do what we were going to say, so G plus AES, fill, let's take out the colors for right now. Color equals, what was it? Factor gear. That's a bit too much, right? So if you're doing 3 box plots with points, I think that'd be fine. If you're doing many box plots, that might not be the way to go, right? So here we're adding a factor for gear. So now we're doing all the interactions between cylinder and gear. Does that make sense? Okay. Now, I want to say there are different ways to present the kind of same information, right? Let's say I want to do facet wrap gear. So in this instance, I mapped the number of gears to a color, right? We just saw what that looked like. In this instance, I did what's called a facet, right? So each one of these vertical columns is a facet, and they separate the data by the facet you give it, in this instance, gear. All right? So this is the distribution of miles per gallon broken down by the number of cylinders, and more so broken down by the number of gears. Okay? So just to make sure everybody knows exactly what I'm saying, tell me the median or approximate median miles per gallon for a 4-cylinder car with 5 gears. About 27. You said 8? What else we got? Just say a random number then, if you're not, any number, R norm out of your mouth. Great interaction, guys. Okay. So, 4-cylinder car, 5 gears, around 27. Right? We good? Everybody understand that kind of plot? Now, I want to talk about different types of faceting. So there is facet wrap, right? I use that for the majority of things. And there is facet grid. And these are very powerful tools. In this instance, they look exactly the same, facet wrap and facet grid. So, although I said I wasn't going to, I'm not talking about the project. This is very important, for example, when you had data on like days, right? Like if you wanted to plot like a density of counts by day, facets are really, so densities, for example, sometimes are very helpful. Facets can be more helpful depending on what you want to do, right? So you could easily do, let's do that kind of plot. Let's do a density plot. What do you need for GM density? You need an X and a Y. Why do you need a Y? It's weird. Maybe let's do GM. Yeah. We gotta look. Y not found. Anybody got any idea on that one?
Are you trying to do density of
The miles per gallon. It should just be X.
I always get it wrong.
And they'll yell at me there's no
It's
Y.
default.
Oh, there we go. Look at that ugly thing. Alright. So, densities, ggplot. By default, they make these polygons, right? So, let's do density. So, in base, you do plot. Let me make this bigger. Plot, density, df, mpg. Usually you get something like that, right? Says all this other stuff about the bandwidth, how the smoothing went, all that kind of stuff. It's usually the defaults. But when you do it in ggplot, it has this weird line at the bottom. So, I think this is good to know because I do densities a lot, right? I do distributions usually by like a kernel density estimate. That's what Jeff was talking about in class. Look, I'm just wrapping class right back in there. But the majority of it encodes it as a polygon because a lot of times what you want to do is fill that with something. So, like, let's say D plus AES, fill, what do you guys want to fill with? Let's do, oh look, you filled it with colors by the number of cylinders, right? There's a whole bunch of overlapping that you can't really see, which is not so great, right? And I'll show you in a minute how we can maybe do that with like some alpha blending. But I don't think filling the actual thing is a really good idea or really an aesthetic thing I want to do. So what I usually do is I don't use GM density. I use GM line stat equals density. So this is different. In that it doesn't give you that weird polygon thing. It doesn't also go to 0 necessarily. So you usually want to, a lot of times, do, all right, tell me how to change the Y limits. Chords dot, what is it? Underscore Cartesian. Okay, is it a vector?
Yeah, it's C for X and Y lens, and then you can also do it for the limit.
Yeah, I'll just for right now I'll just do Y lim because I didn't want to. I'm not going to change X for right now. That's a good one to know as well. So I changed the Y too much. Okay, goes to 0. Right? Note that if I do this, the filling thing again, things aren't going to go right. It separates things out. Right? I also put the limits, which aren't going to be right anymore. But for right now, let's just keep it. let's just take the limits off. So it'll separate things out by cylinder, but it's not going to fill them, right? So lines don't have fills. Lines have colors. Contours or polygons have fills. And that is the plot I would normally make in lieu of this one. Okay? So, I still am just hating that legend outside.
Wait, sorry, you were gonna get to facet wrap.
Oh, yes. Facet wrap. Good call. So we got the facet wrap and we showed the gears. Okay. Oop, that's a G now. So facet wrap, we'll separate them by like that kind of thing. By the number of gears, but it'll allow you to add like number of, and let's do gear plus carb. Let's show that one. So this will do like all combinations of like gears and carbs. I don't think I want to necessarily do that. That was all the other ones are not very categorical. I don't believe. Right? What is it? AM. Is it American or not? There we go. So apparently America only makes like 4 and 5 cylinder cars. They have no 3, right? If we factor that, it will be, I think, a little different. It should make things, at least one layer must contain all variables used for faceting. So, what I want to talk about is facet wrap takes in, I mean, again, I love the packages. The description's just confused. Like, wrap a 1D ribbon into 2, I don't know what that means. So, you put a formula in here. So, usually, a lot of times, I'll just do like tilde and then things plus each other. And I mean that in the sense you can do like a y tilde x. And that changes the order, usually, in which things go. So 0 in this instance means it's not American made. 1 means it is American made. And then it means the number of carbs.
So how's it different than tilde gear plus and?
Yeah, that's a good question. Let's do this.
It's the XY, so whether or not it stacks it. Yeah, but I would think you would just flip it around the tilde. So one has the facets on the X and one facets on the Y.
So like, it doesn't. In this instance, those are the same points plotted in the same order. It just 0, 3, 0, 4 versus 3, 0, 4, 0 means like this one's plotted. The first thing is the thing before the comma is the first X. The thing after the comma is the second X. We should. Oh, let me just. Okay. Let's make. All right. This is what we're gonna do. Let's.
There were labels. I think I'm just getting confused about that.
Yeah, they don't put labels by default. Let's try. This is. So. V or S? Well, that wasn't even American. It was a manual transmission or an automatic. What would that be? I don't know. Anyway, so I'll show you that one. So a lot of times I don't necessarily want it to do. I want it to do things in like maybe I want, bless you, maybe I want only one column, right? This is a terrible plot and this is totally ugly, but a lot of time I just want to show you that like n row can actually facet things out into things. Will allow you to facet so that it's similar to par MFRO, right? When you do things in base graphics. So note, par MFRO and that kind of stuff do not work with ggplot2 graphics, right? They're called like globs, and you have to work with like the grid package if you want to like assemble things together. And that kind of comes me to the next point. So I would say publication figures, a lot of times I will use this, and I will maybe use like Adobe Pro. So the reason for that, and although it's not in some respects reproducible in that I can create the last figure by Adobe Pro, Illustrator, Adobe Illustrator. And I say that because if I drag and drop into a Adobe Illustrator graphic with like a PDF, like for example this figure, and then I regenerate that graph and it's different, it'll update on my Adobe Illustrator. Okay? So it still is like synced up, but it's not necessarily fully reproducible in that respect. The other option I would do to assemble things that sometimes don't necessarily, might not be the best at doing, I would use LaTeX. Right? So one of those two things I would say, you don't have to do every single, I would say you have to do every single plot usually in code for like reproducibility, not for this class, but like in general that's a good practice. But like combining things, I would probably use a different system because sometimes the devices in R, it isn't super easy to get everything in the exact layout that you want. Okay? All right, so then there's Facet Grid.
So what's the difference between the two?
Sorry, Facet Grid and Facet Wrap. So here's a good thing. That's a good question. You can change, and usually to me, there's not much of a difference for most of the stuff I do. The difference is in a lot of times how you want the scales to kind of work. So there's two things. One, you'll see in a minute how it labels things, and two, the ability to kind of free up the X and Y axes at the same time is not, the behavior is not the same in Facet Wrap as it is in Facet Grid.
So can you free up with grid and not wrap?
Other way.
Yeah.
Other way
I
around.
thought I just saw it in
You can free it, but it's so okay. That's a good. Maybe let's do something else. Because all these axes are the same for the most part. Well, no, that's not true. I mean, all the x-axes are the same. All the y's one there too. So that's not very. Well, I think that's because by default. So let's say scales equals free. Okay. Oh, come on. Okay. All right. Now, I freed both the x and the y axes. Okay? Now, things aren't really comparable across columns. Things are not very comparable across rows because both the x and the y are free. Let's free the x-axis for now. So, things still are comparable across the y-axis, but not necessarily the x here, right? This is an 8-cylinder car, this is a 6-cylinder car, but you can kind of compare them, right? So if you free both, and you can free the y, but it'll keep the x. But I'll show you what happens in Facet Grid when you change that. So now you can compare the same cylinder cars, but you can't really compare them across rows. So in this instance, it's not that helpful because you want to keep these things relatively fixed. Here, let's bring up a figure I made, which was pretty okay, like this morning. Okay, so don't necessarily have to worry about the problem of this, but we had raw data and we had normalized data. So the raw data goes from 0 to infinity. The normalized data is pretty much centered around 0. So I don't want to enforce necessarily that these have the same axes, right? The x-axis at all. No, and because I'm plotting a density, right? So for example, like a super concentrated density versus some densities that are more spread out, this y-axis can be very, very different. It can be like up to like 0.5 versus things that are like to like 0.1. But like I don't really care if this one like goes all the way to like 0.8. I'm just looking at the shape of the kind of distribution, so I freed up the y-axis as well. So this was one instance where freeing up the y and freeing up the x made sense. Okay. But that's not always the case. So at the end of the day, if you're doing facets, you want comparability usually across something, right? And in this instance, if you take them away, if you take away the take away some of these scales, it doesn't work the same way. Or sorry, there's no comparability. Okay, so facet grid, a little bit different. A little bit different the way it plots it, right? So the top factor is on the top, or sorry, the very first factor you put in on the x, it's on the top. The second one is on the bottom, but the behavior is very, very different when you change y's and x's around. So although 3's and 1's, this, in this instance, looks, I think, a lot better, right? So it's like a table, right? Column 1 is cars with 3 gears. Row 1 is whatever VS being 0 means, right? So these cars are V's. I don't know what that is, but.
So that's not what Rap was doing?
That is not. So let's let's compare the code back to back. Let's quotes.
It is. It's just like labeled.
It is. Okay. Let's
like that labeling is more clear. Like what is actually.
This labeling is more clear, but also let's do this. df2 is df so the vs being 1 and 5. vs being equals 1 and df gear equals 5. So I'm taking out, right, a different thing. So I'm going to call G2, and I say G. And for those who've never used this, so there's the percent plus percent, right? So this allows you to create a plot, but reset the data, right?
So it overrides like the data that's already in there?
It overrides the data that's already in there, correct. So empty plot. No plot, right? Different behavior. Okay, then let's go to the freeing real quick, and then we'll talk about some more general things on how to like make these things bigger. Put the stupid legend inside. Facet grid. It says like free. Right? But they're not free in the same way that these are free, right? So look at the x-axis. It does free up the x, but it will only remove the 8-cylinder cars when both of these in this column do not have an 8-cylinder car. Right? Whereas if you do it in facet wrap, it doesn't care.
So it's like treating all those as separate graphs, basically.
More or less, yes. Okay. When you free up the scales. Anyway, okay. So we had this. Let's go back to this one. Nope. Okay, let's do this one because I didn't like the other graph anyway. Okay, so now shout out things to make it better.
Relabel that axis.
Tell me what. All right, another person. I got places to be. Like, I mean, if you come on, give me something.
A question. So
Yeah.
if we add a title, but that title does not, if that title says the same thing as the absence.
So like density versus whatever. So two things. A lot of journals, for example, you wouldn't necessarily have a title on a plot, on a single plot like this, right? You would put like a big, you would put that in the figure, and by Jeff, I'm not really sure what he meant by like a title for a plot. Usually that means like figure 1, the next sentence, the next like 4 words are like the title of the plot. You can also have titles on plots. It depends, but like for example, for like because a lot of times you don't just have like a single figure like this. You'll have like a multi-panel figure, so it'll just be like talking about like distributions of or something like that. But let's give this one a title. So give me a title. What am I looking at? Distributions of what? I'll put MPG. Just say like we talked about it in the paper, and we put it in the caption: miles per gallon parentheses MPG. By what? Cylinders. By numbers of cylinders. So note you can put that thing in there. Sorry. You can put a /n for a new line.
Do you have to paste it?
No, I just did it for code.
Oh.
I didn't put anything in there. You can density's still okay to write in there. I just would capitalize it maybe. What? Why did it not like that? Oh yeah, I gotta print it again. Good call. There we go. Okay, it's looking better. Somebody get this figure. Somebody get this legend out of here. Put it in. All right. First thing I want the title for that legend changed.
Still underscore as underscore discrete and then change parentheses name equal to
Name.
equal number of
Let's see. Let's just see. Let's just try that. Let's see what we got. What is breaks? So yeah, scale color, discrete.
You use that scale X.
Yeah. So you have to know what what aesthetic it was mapped to, right? Okay. So let's look at that one real quick. So look at discrete scale, aesthetics, labels, breaks, any value, guide, legend, limits, all that kind of stuff. Okay. So I'll show you guys a little function that I like that I made. So I like transparent legends. So transparent legend just takes the theme, sets the legend background to be transparent, sets the keys to be transparent. And I want to do one other thing. Somebody tell me how to position the legend to a different spot other than there. Dot. 1-1. Okay, let's try 1-1. Oop. Gotta get out of help. Sorry. Forgot to run that. So 1, 1 goes to the top right of the entire thing, of the entire object. So for x, let's go about 80% of the way. Y, we can go about 80% of the way as well. Okay? So, why did I make it transparent? Just in case I put it somewhere. Like it doesn't, if I take out this, whatever, I don't know. We have that. If you make it transparent, so note 2 things when we jump back and forth. 1, big box, obviously. So you can't see anything behind it, right? Also, there's a box around the keys. When we do this, so there's no big box. That kind of makes it transparent. And also, these keys are transparent in the sense that, like, although, here, I don't know, I should just show you, because that's just easier. So without the keys being transparent, they have these little boxes on top of them as well, which takes out the grid lines, which looks okay if that, I mean, but that's not my necessarily preference. And I'm not saying that there are not a lot of preferences I have, but some of them are pretty good rules. And again, I would ask Elizabeth in class why she talks about Scott giving her the information that legend should always be inside. Now, we could also make it horizontal, right? Legend. So you just go through all these things again. It's direction. So that again, that is not anything that looks better or worse. Sometimes it's easier to use a horizontal one versus a vertical one. That one looks probably pretty bad unless I like change it to like 7 and then maybe like 9 to put it up higher. Right? We can also thicken up the keys, right? They're pretty big. All right, now, the biggest thing I will say before we kind of like end up here, every single time, text needs to be bigger. So, in general, you can just say text, element, text. This is a problem because everything will get very, very big. Maybe that is not. Right? So you want things to be pretty big, I think, with respect to text. And then if you look at theme, there's like 100 different things you can do with text. So there's axis. Text controls everything that is a text element. Axis text, legend text, there's usually a title text. One thing of note that I don't know why it's not called facet text, but it's called strip text. If you want to make for example, let's go back to our facet example. If you want to make these letters bigger, you'd have to say like theme strip.text equals element text size equals like, let's say 20. Let's make it very, very apparent that we changed them. Right? So theme is the way you, okay, so at the end of the day, the whole take-home message is ggplot2 are okay. Sometimes the default colors are not that great, especially if you want to display things in a certain way. But you should heavily use theme to customize your plots. In general, to make text bigger, label your legends, make the legend text bigger. Sometimes legends don't need like that number of cylinder thing, right, that we have, right? The keys are explicit on their own. This one, it wasn't, right? We wanted to actually put the keys. Okay, so somebody give me like a brief, not for this one. That one's not what we were working on. Somebody give me a brief, quick description, right? So this would say like figure 1. And in the next line words it would say like distributions of miles per gallon, parenthesis, MPG, by number of cylinders in empty cars, right? That would be like my figure. Title, right? But I wouldn't necessarily put this up here. You can though, again, and if it's a one standalone figure, that's fine. So, all right, somebody tell me what I'm looking at here. I'm looking at distributions. How are they estimated? By magic. You're right, by magic. No. Kernel density estimates, right? Show the we are showing like here are the distributions of the miles per gallon by the number of cylinders in a car, estimated by kernel density estimates, and then like observe something. Somebody tell me something. Do you want an 8-cylinder car if you drive a lot? No. Why?
Because the overall it has lower miles per gallon.
Yeah, so we see a large mode here, the miles per gallon to be around 15. So what would you say about maybe you want a 4 miles per gallon car, or a 4-cylinder car, right? But what would you say maybe about that? What would you say maybe about the spread of that distribution compared to the others? It's larger, right? So there's more variability in the miles per gallon in 4-cylinder cars, although on average they probably have better miles per gallon. But there is some instances, and there is some part of that distribution that a 6-cylinder car could get you better gas mileage than some of these, what I would call like bad 4-cylinder cars, right? So this is the type of things I might say in a figure, right? You don't just want to say, here's the figure, it looks great, right? You want to tell somebody something that you saw and why you put it in, right? So just the way I think I said in some people's papers to like justify why you thought this data was good or justify why this method, justify why you made a figure. Like, why should I care? It's like, like I don't, knowing someone can make a good figure is not like why you read a paper. It's like, what did you see that you wanted other people to see? All right? And assume everyone's pretty blind. Just everyone's blind. They can't read small letters. Right? That's what I assume. Everybody can't read small letters. Okay?
I do have a question
Yeah.
about terminology. So for both the x-axis and y-axis, the like miles per gallon is the label, right? But what about the numbers? What is it called? Is it
What do you mean?
what is it called? What is the
These
terminology?
ticks, like the scale.
Yeah, what is the terminology for this?
So
Let's say we want to.
scale x discrete, right? So scale x will give you the same things, right? So let's say I want to go from 0 to 40 without using necessarily x number. So scale x discrete, and I want to say brakes equals, what do we have here? Let's do 10, 20, 30, 10, 20, 30, 40. Okay? Right, if we want to change that axis a bit up. Oh, what did I not do? Oh, they are continuous. What happened to my legend, though? Did I not oh, you have to add it to the plot. Am I missing something here? Oh. I have a silly. So, like that's how you could change around the brakes, right? We could do, and then you could say like, for example, on that it gives you labels. Good or great. Oh yeah, it's great for the pollution. So bad or worst. Let's say bad, good, great, maybe. It was the brightest. Okay. Okay. 40 is outside the range of the data, so it's not actually mapped. Okay? All right. I will upload this. Have my lovely YouTube video with. I didn't mean like I have somewhere better to be in the sense I actually do. I mean, I just wanted you guys to answer some questions. That wasn't clear. Alrighty. Thank you all for your time.